Welcome to Guru Nanak Institution's Technical Campus, an autonomous institution accredited by NAC and NBA. Here's a short review of our world-class innovation center. First is our Team Wraith Racing Center. It was established in the year 2013. It has 33 students from the field of mechanical engineering. Out of all our achievements, we pride ourselves in bagging the first place in Telangana at the Endurance Student India 2017 event. Next is our Solar Power Applications Lab. Here, we train the students to make them aware of green power and to do research in the field of solar power. We've successfully completed 57 major projects and 41 mini projects. One of our main projects include designing of solar generating plant and parameters affecting generation of solar power. We've also installed 2 solar power generating plants in the campus. Next is our robotics lab. Our Robotics and Industrial Automation Research Center was established in the year 2013. This lab deals with design and implementation of robots for various applications. It includes electronic, mechanical, and pneumatic technology along with programming. It is used by our electrical, electronic, and mechanical engineering students to complete their mini and major projects. Till date, more than 600 students have been trained in this center. Some of the excellent projects developed at the center are humanoid robots, spy robots, pick, use and place robots, omnidirectional robots, and many more. Next is our Big Data Lab. It was established in the year 2014. We have been developing the projects for commercial applications, social network, medicine, and scientific areas. It includes lots of tools to process and predict the future. Here, CSE and IT students complete their mini and major projects. So far, 550 students have been trained. With our 3D printing rapid prototyping equipment, we make 3-dimensional solid objects from a digital file. This helps our mechanical students to make prototypes for their mini and major projects. Next, we have our Entrepreneurship Incubation Center. Here, we help our students to develop their ideas to become a successful entrepreneur. We provide them management training and office space for their startups.
Guru Nanak Institutions is one of the largest educational groups in India with 10,000 plus students from various countries currently enrolled in engineering, management, medical science and pharmacy. Our college has students from different countries. They are students from different geographical and cultural backgrounds such as Afghanistan, Sudan, South Sudan, Nepal, Yemen, etc.
A full-fledged training and placement division with highly dedicated staff and modern students are available in our campus. We are trained from second year onwards in various areas such as aptitude skills, soft skills, technical skills and interview skills. The training and placement division creates immense change in the overall personality of the student so that we are placed in various MNCs. The general manager of our college is Colonel Retired Rajesh Kumar, VSM. He is responsible for taking care of the administration like the girls and boys hostel, transport facilities, etc.
GNI have multiple cafeterias and food courts where quality food are available to the students and staff. There are different types of cuisines available in our canteen.
Is our computer science department. Our CSC department have a pool of well-trained faculty members. We have well-equipped labs with latest hardware and software which gives us the opportunity to learn and practice. Our department conducts various seminars and PowerPoint presentations which keeps us abreast of new developments. GNI provides ultra-modern and well-guarded hostels for boys and girls. We have very good facilities at hostels. Students from various countries and states stay here for 4 years. The hostel environment makes them feel homely.
Our college has an indoor sports arena named Gametron where students can play games such as badminton, chess, carom, table tennis and snooker. There are two ways of spreading light, to be the candle or the mirror that reflects it. We at GNI offer students to empower, enrich, enhance with our innate endeavor.
Hello, my name is Gungam Taipuda and I'm from Arunachal Pradesh. I'm doing my MBA from Guru Nanak Institution. The infrastructure of the college is very modern and sophisticated. Facilities provided to the students of other states and countries are really nice, like hostel facilities, playground, gym, separate lab and library, etc. Being a student, I'm glad that I chose this institution as we are getting paid internship from college itself and I'm working in accounts department as an intern. Apart from that, GNI offers various courses like BPharm, PharmD, BTech, etc. The staff and faculties are very experienced and cooperative with students. Overall, GNI is one of the well-known educational groups of India. Thank you.
My name is Shalini Mishra and I am a Nepali national. I am currently studying in final years in CSC department and I am very proud to say that I got placed in my 4-1 in a very good and esteemed company, that is IBM. I would like to thank the training and placement department of my college and I would also like to thank GNI management for providing me such a good opportunity. Thank you.
Welcome back to the session. Now I would like to invite Dr. K Jagnadarao, HOD, Civil Engineering Department, to introduce our first keynote speaker, Dr. K Jagnadarao, Professor, Department of Civil Engineering, CVIT, Hyderabad.
Dr. K Jagnadarao, Professor, Department of Civil Engineering, has over 14 years of experience in teaching. He working as a professor in the Department of Civil Engineering and Joint Director, Students Affairs and Progression, CBIT, Hyderabad. He is actively involved in various national and international conferences, workshops as a member of organizing a technical committee and chaired technical sessions in many conferences. He was also a recipient of SAR MV Awards instituted by Smart Interest for the year 2019 under the category of academicians. He also served as an expert member in prestigious committee AP Public Service Commission JNT. He is also an evaluator for AICT proposal under AQIS. He authored a textbook on structural dynamics and earthquake engineering published by SK Kataria and Science, released on January 2019, and revised a textbook on RCC design by BC Punmiya Lakshmi Publications. He has contributed a book chapter in Advances in Structural Engineering, lecture notes in Civil Engineering, Volume 74, Springer. He also editor for Proceedings of International and National of Steel Structures by S.K. Dugal, Tata McGraw-Hill. He is a life member of Indian Congress Institute, ICFRC, ISTE and Fellow of Institution of Engineers. Now, I would like to invite Dr. K Jagnadarao to give lecture on sustainability aspects in civil engineering.
Well, I'm very happy that Guru Nanak Institution's technical campus is organizing a national conference, and the main objective of such national conferences is to bring academicians, research scholars, industry professionals, consultants and all such people onto one platform to discuss and deliberate about the latest issues, latest advancements in materials, latest technologies and latest management methods, all these things. So I appreciate the efforts of Guru Nanak Institution's Technical Campus in conducting this conference, and I'm sure the participants would definitely get benefited about this, and also the papers received of good quality, and I congratulate all the authors also for submitting the papers to this conference. And though it is pandemic and we are doing it online, and in a way it is convenient for all of us to attend the conference, otherwise, and it saves a lot of logistics expenses and other things also. Otherwise it would have been very difficult to attend the conference, to take out time. One day is also in these days of computer era, it is very difficult to take out time, but because of this probably we all could participate in a better way. So this way we can take this pandemic situation also in a positive way. And so many such conferences I have attended in these days, and training programs, and we also got exposure from the IIT professors and great gurus online because of this situation. As Professor Anil Sasruda of AICT chairman mentioned, this we have to make use of these situations and try to acquire more knowledge and use it in a fruitful way. The members of the management, Guru Nanak Institutions, the organizing committee, the patrons, Sardar Tavinder Singh Kohli, chairman, GNI, and Sardar Gagandeep Singh Kohli ji, vice chairman, GNI, and the conference chair, Dr. H.S. Saini, managing director, GNI, Dr. Rishi Sahil, associate director, GNITC, conference co-chair, and head civil engineering department, Dr. P. Jagadishan of GNITC, and the dignitaries from the Institution of Engineers and distinguished delegates from various organizations and institutions. A very good morning to all of you. At the outset, I thank the Guru Nanak Institutions, and in particular and in general the organizing committee members of the conference for having invited me to deliver keynote address in the conference RACE-2020, that is Recent Advances in Civil Engineering. Well, I selected a topic which is on sustainability aspects in civil engineering. So in this I will be talking about sustainability in general, the first part, and second part I will come into the civil engineering. Now, the facets of the conference my lecture would cover. The first one is what is sustainability, then elements of sustainability, that is environment, economy and society, then sustainable civilization, what is sustainable civilization, and sustainability problems and solutions, what are the problems of the sustainability and how to overcome these problems or methods. Then sustainability aspects in civil engineering, that is there are 5 phases basically. First one is pre-building phase, then building phase, then post-building phase, preservation of natural resources and natural conditions, then human comforts. These are the 5 aspects in civil engineering. And then sustainability in civil engineering works. During the progress of the work, what precautions or what aspects to be considered. Then alternate construction materials which are available in civil engineering, and sustainable practices finally in buildings. Once the building is completed, what practices are to be followed in the completed buildings. And finally, conclusion. So, what is sustainability? Well, it is meeting the needs of the present without compromising the ability of future generations to meet their own needs. So, in this there are two aspects. One is we have to preserve the resources, natural resources, whether it is finite resources or renewable resources for the future generations. That is one aspect. And the second aspect of which is we have to preserve the environment also. There should be quality life for the future generations. In other words, we can also say this as living within the regenerative and assimilative capacities of the planet. Now, what are the elements of sustainability? There are three elements, that is environment, economy and society. Let us take the first element, that is environment. There are several factors in this. The first one is materials, then energy, biodiversity and physical interactions. Now, as far as materials are concerned, we have to minimize the use of materials, that is judicious use of materials in the construction. Then, or any process in general. Then energy, we have to conserve the energy, use the minimum energy in the process, right? Then biodiversity and biophysical interactions are also equally important, because we have three systems, there is human beings, nature and animals. There is balance among these three. So we have to maintain the balance. Ecological balance is to be maintained. The second element is economy. Again, there are several factors in this: money and capital, employment, technological growth, investment and market forces. Now, suppose there are two systems. One is a conventional system, the other one is a sustainable system. Now, if suppose the sustainable system requires more initial investment, more capital, obviously it requires more investment. So, in such a case, people may not go for or may not prefer that one, that is about initial investment. Though life cycle costs are less for the sustainable processes or sustainable structures, still people, they are not ready to spend huge amounts in the beginning, that is for the earlier investments. So money and capital investments, then employment. Then if you take up two processes, one industry, conventional one, and another one advanced technology, that is a sustainable system, then this may require lesser number of people and more skilled. So again, people have these struggles. They have to get the skilled people, or if they take the people, they have to train them. So this process, people may not go for this because of these aspects also. Then like that, these aspects, technology also, one particular case as already mentioned, the conventional process, the other one is a sustainable method. The advanced technology, as already mentioned, which may require skilled people and huge investments. So this way economy plays a vital role in this. Then third one is society. So here, apart from these two, we also have to meet the requirement of the society, like human diversity, equity, quality of life, institutional structures and organization, and political structures. So in this, for example, if you take the human diversity, let us not discuss more about this, but still in this we have various cultures, languages and ethnic in the society we have in the globe in general or in our country. So you have to meet the requirements of different sets of people or different regions of people or different culture people and different languages. We have to meet the requirements of all these things. Then there is dependence and independence as far as equity is concerned. So when I talk the case of dependence, it is not only one another among the human beings, but also among different systems. One is you have the human beings, the nature and the animals. So these three systems are interdependent, all these three, but unfortunately we are not contributing to the other two. We are taking from the nature, we are taking from the animals, but we are not contributing to them. Unlike the other two, the animals, they take from the food from the nature and again they give it back in the form of compost or something like that. Similarly, the nature also contributes to other two, whereas the human beings, we don't contribute that much. Now, coming to the economic growth again, economic growth must be made less material intensive and less energy intensive and more equitable in its impact. This already we had discussed. So we have to minimize the use of materials, and also we have to use sustainable materials or the alternate materials to the finite resources about this. Then economic growth may be reduced are curtailed to meet limitations imposed by environment, technology or society. As already mentioned, there are two systems. One is a conventional system, other one is sustainable system or industry or some equipment. Then if suppose the conventional one is emitting a lot of pollution, then environment may impose, that is the government or the local authorities may impose certain restrictions on that. So though it is slightly expensive, we have to go for, or we are forced to go with the sustainable system only. Then what is a healthy community model or healthy community? When these three elements are satisfied, that is society, economy and environment, these three are satisfied, then it is called a healthy or sustainable environment or model. Then what is sustainable civilization? Any industry or any system in general, you have the input, then the process, then output. Not only the industry, even in the case of education institutions, if you take, you have input, the students, what we get, and then process, the methodology, the delivery methods and all. Then finally output is the knowledge, skills and attitude that is imparted to the students, that is output. So in the case of industry, you have the input as energy and materials. So these materials, the use of materials must be minimized, that is you have to use the materials judiciously, and the energy also it is to be conserved, that is minimum energy, you have to minimize the energy. Then these have to be renewable also, the second case, that is instead of going for finite resources, you have to go for renewable resources. Then coming to the process, it should be energy efficient and it should not lead to any toxic effluents, that is toxic materials are to be controlled and waste also is to be minimized. So when there is a system which is taking care of all these three, then obviously you get low quality heat energy in the output material, so which requires less efforts to cool it down, and also the low volume non-toxic waste materials are produced out of this. Then this system is called sustainable civilization, right? So input level, it should be renewable, and process should be energy efficient, and toxic free system should be there, and waste is to be minimized, and output ultimately you get low quality heat energy and low volume non-toxic waste. Such civilization is sustainable civilization. Problems of sustainability. So what are the problems? The first one is depletion of finite resources, that is fuels, soils, minerals and species. They are getting depleted day by day because of over exploitation. So in this fuel, soil and minerals, they come into our civil engineering aspect, and because these two in soils and minerals we use coarse aggregate, fine aggregate and tiles as granite or marble, etc. And fuels are required for running our equipment, the construction equipment. Then the second one is overuse of or over exploitation of renewable resources. We have forests, fish and wildlife, fertility and public funds. So out of these forests and fertility, these come into our civil engineering aspect. So depletion of forests is a major problem, because the way the plants are grown or forests are grown is much less than the way they are cut or felled. So this is leading to deforestation. Then the soil also gets infertile if you repeatedly use it. So by using crop rotation or other methods and using organic compost and all, we can increase the fertility of it. So this is another problem. Then third one is pollution. We have soil, air and water pollution. We know all these three, and we are all affected in fact by this one. Now a simple example for this is now this pandemic, though it is COVID-19, it has caused some losses and deaths and other aspects, negative aspects are there. There are certain positive aspects are also there. In one of the newspapers, I think about 2 months ago, I have read that the water in the river Ganges, that is river Ganga, it is pure in most of the places. That's what it was reported. Then coming to the air pollution, then there is an article again in the newspapers that from Jalandhar, which is about 400 kilometers plus from the Himalayan range, people are able to see the Himalayan range from Jalandhar, Punjab. So this is positive aspect. So why this is happening? Because of over exploitation of natural resources and the increase in carbon footprint, pollution, smoke and all. Then these three are basically engineering aspects, and then we have problems of the other two, inequity and species loss. These are also to be taken into account. When we talk about sustainability, the economical, political, social and gender equality also is to be there, is to be balanced, and species loss, that is endangered species or extinct species, are also to be protected. So these are the 5 problems we face only. So what are the remedies for this, to overcome this, or what are the solutions? We have, the first one is cyclical material use, that is emulate natural cycles, that is RRR, reduce, reuse and recycle. So the materials consumption must be reduced, that is first stage. Second stage is you have to reuse it. These materials which are used, once its use is over for a particular purpose, we should be able to use it in a different way, right? Then third one is it should be able to dispose of easily, that is the materials with what we have used, they should be able to mix with the mother earth. So these are the 3. I want to share on the lighter side a simple story about reuse of it. One person purchased a dhoti, and for a couple of times he has used it as dhoti. Once its use is defeated, then what he does is he torn off it into 2 pieces and then started using it as cleaning for utensils or gas stove, etc. Then after a couple of uses, again it has become unfit for that purpose also. Then he folded it, stitched and started using it as doormat. Then it serves that purpose also. Then what he did is split into small ropes, and then he started using it as wick for lamps. So these are all the ways on the lighter sense, right? So this is about RRR. Then coming to the second point, it is safe and reliable energy. So the energy, well, safety is very important, and also reliability is very important aspect. For example, if you take an example of an industry which is totally dependent on hydroelectric power, during monsoon you will have maximum flood level in all rivers, and the reservoirs are full, and you have a huge head, and you can generate the surplus power. But during the summer seasons, the water gets exhausted, and you can't generate the electricity from hydroelectric projects. So if it is solely dependent on that, you have to shut down the factory or industry. So this should not be the case. There should be an alternate. So, or if you are using a particular source, it should be reliable. If it is not so, you have to look for alternatives also. So in this there are 3 aspects, that is conservation, renewable energy and substitution. So conservation is you have to minimize the use. Then renewable energy is you have to go for alternate energies like solar power energy or tidal power, wind power, etc. Then you have to have a backup also. That is third aspect. Then these 2 are engineering solutions, and third one also, about 4th and 5th one, life-based interests are also to be met with. That is health, creativity, communication, coordination, appreciation, learning, intellectual and spiritual development. All these are also very important when you talk about sustainability. So regarding coordination, again I want to share one point. Nowadays, of course, the government, there is good coordination in various departments of the government, but earlier R&B people or local bodies, they come and lay the road, and the next day electricity people will come and dig the trench for the laying the cables, and then they leave it like that, or maybe they just dump the soil in that and leave it without bothering about the top coat. Then the next day again waterworks people or sewage people, they will come and dig the hole, again leave it like that, and after a couple of days, maybe due to rains, the entire road will become, or it will turn into the lakes, pools and nalas, right? So this is the fate earlier, but now I think it is improved a lot. So now we will come to civil engineering, sustainability aspects in civil engineering. So what is sustainable design? Sustainable design is the one which reduces the negative impact on the environment and human health, thus improving the performance during building's life cycle. Well, careful consideration is given to water, energy, building materials and waste. So here, not only the input material, these are water, energy and building materials, these are input. Not only input material, but the process, the construction process, construction equipment used, and also the output. what is the waste generated out of this is also considered when we talk about sustainable design. So there are 5 phases in these aspects. First one is pre-building phase, that is site selection, building design and building material process, and construction technology and equipment. So in the first phase, that is pre-building phase itself, we have to keep in mind the planning aspect of it, then what equipment is to be used, what materials are to be used, and how to dispose of the waste. All these things are to be planned properly. So the very first one, a simple example is now, we all have studied the principles of planning and building technology. So you have to orient in the building in such a way that it derives the maximum benefits out of the natural resources, like the breeze and lighting. When the morning sun rays fall in the kitchen, that automatically kills the harmful bacteria and germs. So we don't require a special, or we can minimize the use of disinfectants and all in this case. Similarly, the breeze, if you design orient in proper way, then the air conditioning may not be required, or even if you use the air conditioning, it will be very efficient, right? So this is first phase. Then coming to the second phase, that is building phase, the construction and operation processes reduce the environmental impact of resource consumption. We should see that the process and the operation process and the construction methods what we follow, they should have least effect or least impact on the environment. Then long-term health effects of the building environment on its occupants are also considered. After all, why a shelter is built or building is constructed, it is for the health and happiness of the individuals. So it should take into account the healthy atmosphere, right? Now here, I would share one example. Like suppose if you are going for a cellular type of construction, a solid concrete wall for the walls, reinforced walls. Then if you go with a solid wall, I have heard of it. One place they have constructed and somebody asked me whether can we go for that directly. In that case, because it is a good conductor, a solid wall, concrete wall, so it heats the building. By the time you return home, it will be very hot. So even if you go for air conditioning also, it causes a lot of you can say the efficiency is reduced and it consumes more power, and in turn it also causes pollution, atmospheric pollution, right? So this is an example for that. Instead you can go for a hollow space between the two walls, or the solid walls. If you use proper materials, insulating materials on the inside, that increases the efficiency of the building. Now the third one is post-building phase. In this, old materials become resources for other buildings, as I already mentioned. So minimize the materials, use of materials, and then reuse. That's what is this one. Or waste to be returned to the nature. That is, if it is, as long as it is useful, use it for some other purpose. Suppose you have dismantled a building, existing building, to construct a new building. Then the windows, doors, etc. are useful. You can use it again for some other structures, some other buildings. Or reinforcement in the slabs, you can extract it, right? So this is one way. Second thing is the waste which is dumped, that has to be disposed of easily. That is, for example, if you use plastic, it is non-biodegradable. You are not supposed to use it, right? So the sustainable design strategy focuses on reducing construction waste by recycling and reusing packaging and excess materials. Then, preservation of natural conditions. The impact of a building on its local ecosystem has to be minimized. The impact of your construction, or your construction should not impact the topography of surroundings or plants and wildlife in the surrounding areas. Okay? Then, human comforts. This also has to be taken into account while planning. A building's design should enhance the work and home environments, because an ambience, you create an ambience which is comfortable, then automatically the performance and efficiency increases. So this can improve productivity, reduce stress, and positively affect health and well-being. Now, coming to sustainability in civil engineering work. So to summarize this, in civil engineering works, sustainability means restricted usage of the construction materials directly available in nature for maintaining the ecological balance. So there are two ways of doing this. One is minimize the usage of construction material directly obtained from nature, like river sand, granite, stones or aggregates, teak wood, etc. And second one is go for alternate materials available in place of the conventional materials like granites or wooden centering, etc. Now, why this is to be done? Because it causes damage to the environment. How it is doing damage to the environment? The first one is due to excessive usage of river sand, percolation of rainwater into the riverbeds is reduced, and thereby no recharge of groundwater, causing depletion of groundwater, or groundwater table goes down. Then second one is due to excessive quarrying of granite stones for producing crushed aggregate, the mountains are disappearing. So this also we are seeing even in cities like Hyderabad also, in Jubilee Hills or High Tech City, etc. There are so many hillocks now. So many hillocks disappeared, and it is a continuous process. Still, if you go there, you will find the mountains are being dug out, right? Then, due to high uses of teak wood for doors, windows, furniture, etc., the forests are depleting. So this is another aspect of this usage of or over exploitation of natural resources. Now, we will discuss the alternate construction materials available. In place of sand, natural sand we have, or river sand we have, crusher dust or stone dust, and the other one is manufactured sand or artificial sand. And Robo Sand is one company, and there are many other companies also producing artificial sand, which can be used in place of river sand. Then we have construction demolition waste, which is there, the aggregate obtained from that. So this is also a good resource. So here the process is shown in the form of pictures here. The first one shows here about the dismantling, structured dismantling of the structure. Then second one is the RC component is dumped here. Then reinforcement is separated from this. Then that is sent to the crushers. Primary and secondary crushing is done. Then you will get the recycled aggregate here. Now by sieving you can get the graded aggregate. So why these are not being used? The one point is not having proper awareness among the people, consumers, and second one is they have their own apprehensions about the quality of these things. So a huge publicity is required for use of these materials, because there is a lot of research it was carried out and it is already established. You can use artificial sand, and also code says for non-structural works you can totally use the recycled concrete aggregates, and for structured concrete also up to 25% you can use recycled concrete aggregates. Then these are some of the alternatives for the teak wood. You can use UPVC, MSN, aluminium, door frames, window frames, etc. Then this is about ceramic or vitreous tiles that are available in different colors and shades. You can use in place of granite or marble flooring, these tiles. Then another one is you have MSR, aluminum centering in place of wood, and this shows figure here. The scaffolding is made of steel pipes. So these are all the things we can use in place of wood. Then alternate materials for teak wood are UPVC or PVC sheets for shelves and partitions. Then the aluminum doors, windows with glazed shutters. Then glass for glazing of doors, windows, partitions and shelves. Then other alternate construction materials are, you have solid cement concrete blocks, which can be used in place of granite stones for basement or compound walls or for ground floors. And for first floors and higher floors you can also use hollow blocks or lightweight concrete blocks. And HDP or PVC pipes can be used instead of GIC or DI conventional pipes for water supply and drainage works. Then these are some of the pictures of the solid and hollow blocks. These are the hollow blocks and these are the solid blocks. And this is lightweight aerocon blocks. They are available in 4 different sizes. And when we use these structures, this can be used for non-load bearing structures because of their lightweight. They reduce the bending moments and all, and the cost is saved due to that. And another thing is, they don't require conventional cement mortar for the joints. They can be special adhesives can be used for joining this. That minimizes the thickness also and improves the aesthetic appearance. Now, other alternate materials we have are geopolymer concrete is one, so which is a zero cement concrete. So strength is attained by polymerization here. In the conventional concrete, it is hydration. You get when cement reacts with water, you find CSH gels are formed, and thus it contributes to the strength. Whereas here, polymerization takes place. Then the base material for this is either fly ash or GGBS is used, and alkaline liquids, sodium or potassium hydroxide and sodium silicate, that mixture is used. when these are mixed, polymerization takes place and that contributes to the strength. And another advantage of this material is no water curing is required for this. And curing is done in two different ways, that is ambient curing or accelerated curing. In the accelerated curing, immediately the next day after demolding, we'll put it in oven, that is through hot air we will cure it, that is one way. Within 1 day we can get the strength for this in that case. And if you want to go for ambient curing, you demold it and leave it for 1 week or 10 days, this also you get early strength. Then the other one is bacterial concrete. So in the bacterial concrete, use bacteria like Bacillus pasteurii or any other, there are different kinds of bacteria cultures available. You can use any of this, and there are two ways. One is you can directly mix up this bacteria while mixing the concrete along with other ingredients, and second case is you can also apply on the surface along with this bacteria the nutrients, calcium based nutrients. If you apply, the mechanism for this is the bacteria in presence of moisture reacts with calcium based nutrients like calcium lactose, and it precipitates calcium carbonate, that is mineral precipitation, which fills the cracks. So this is the mechanism here, because it automatically fills the cracks without any special. Another material is self-compacting concrete, which uses the industrial waste like fly ash, and which improves the properties. And also when we use this concrete, we don't require any special vibrating machines, because these material, this concrete settles down, reaches nook and corner of the formwork by its own weight. So when we use this, we don't require the vibrators, and which in turn they consume either electricity or the fossil fuels like diesel for running that, and also they liberate pollution, and the generation of the electricity which is used or the fuel also requires some energy, and also pollutants are reduced. So all these things we can minimize. Then what are the sustainable practices in buildings? So once the buildings are constructed, now what are the practices? So we have the photographs here. The first one here is rainwater harvesting, that is roof water is collected through this pipe into the tank, and this can be used for farming or other uses. Then the other one, second photograph here is solar panel installation, which may be horizontal like this, or maybe inclined panels also you can have it, which is on rooftop for renewable energy. Then here this third one, energy efficient lamps, and of course energy efficient equipment also we can use in the house. Nowadays we have the star rating 3, 4, 5, that is depending on embodied energy, carbon footprint, energy required, all these things. Embodied energy means right from the process of manufacture, then during its operation and its disposal, all these things are considered into account. That is energy star rating is given based on these factors, right? Then the next photograph shows here the use of local materials. This is made of local material, and the controlling of heat trap can be done by growing trees and creepers like this, especially the western side heat can be controlled by using these. And you can also grow the rooftop landscaping or roof gardening is also a best method for controlling the temperature. Now let me conclude with these. Now the first one is sustainability is the need of the hour. Then in civil engineering, sustainability starts from the planning stage itself. So planning stage, that is planning, execution, operation and maintenance, you have to follow the sustainability guidelines. Then follow 3 R's, reduce, reuse and recycle in the case of materials, and reduce the use of energy or conserve the energy. Then use of non-conventional energy, that is renewable energy, and alternative materials for finite natural resources, natural materials is another one. Then use latest materials, that is eco-friendly materials like geopolymer concrete, self-compacting concrete, bacterial concrete, etc. And last but not the least, protect the nature to get protected. So this is very important, protect the nature to get protected, like Vriksho Rakshita Rakshitaha. So we will apply this to entire nature, not only the trees, rivers, water bodies, everything. If you protect them, you get protected out of it. Thank you one and all for your patient hearing, and I thank once again the management of Guru Nanak institutions, and especially the Guru Nanak institutions technical campus, the principal, the head of the department, and other organizing committee members, and my former colleague Dr. Shivashankar Reddy. Thank you all for the opportunity given.
Thank you for your inspirational speech, sir. Now, I would like to invite Praveen Rao, HOD, Civil Engineering Department, Guru Nanak Institute of Technology, to introduce second keynote speaker, Dr. MVSS Giridhar, Professor, Department of Civil Engineering, JNTU, Hyderabad.
Dr. MVSS Giridhar, Professor, Department of Civil Engineering, JNTH, is a Professor and Head Center for Water Resources, Institute of Science and Technology, JNTH. He is having over 25 years of experience in teaching, research and administrative experience. His research interests are remote sensing and GIS application to water resources, integrated water resources management, watershed management, rainwater harvesting and urban water issues. He has published several papers in several national and international conferences. He has organized around 15 national and international conferences along with workshops and training programs. He executed 11 research projects funded by various national and international agencies. He has designed 23 research borewells in JNTH, and every year more than 10 crores liters of rainwater is being harvested and recharged into aquifers after proper filtration. He has also designed rainwater structures in some rural parts of Nalgonda to reduce fluoride concentration in the aquifers. He also designed and executed floating floriculture setup regenerate the span lake. He has designed and executed construction of wetland in the JNTS campus to treat sewage. Now I would like to invite Dr. MVSS Giridhar Garu to give a lecture on water conservation, rainwater harvesting, a new perspective.
Guru Nanak Institution's Technical Campus, Ibrahimpatnam, for giving me this opportunity to deliver a lecture on water conservation, rainwater harvesting, a new perspective. I thank the Sardar Tanvinder Singh Kokhli, Chairman of Guru Nanak Institutions, Sardar Gagandeep Singh Kokhli, Vice Chairman of Guru Nanak Institutions, Dr. H.S. Shaini, Managing Director Guru Nanak Institutions, and Dr. Rishi Shoyal, Associate Director Guru Nanak Technical Campus, Dr. P. Jagadishan, Professor and Head Department of Civil Engineering, Guru Nanak Technical Institution Campus. I thank all the eminent persons in the Guru Nanak Institute of Technology for giving me this opportunity to speak on rainwater harvesting, water conservation, a new perspective as a keynote speaker. And Guru Nanak Institution, this conference is started with the name, with the tag RACE-2020. It's a good title, and on the National E-Conference on recent advances in civil engineering started very effectively in association with the Institute of Engineers Telangana State Center, and lots of topics are covered, and major topics I'll explain. It is more thrust areas covered in this national e-conference is structural engineering, geology and geotechnical engineering, remote sensing and GIS, environmental engineering, transportation engineering, water resource engineering. These are the important predominant topics in the civil engineering, and it is a papers and conferences focusing not only these areas, all advanced topics in the area of civil engineering in association with the Institution of Engineers Telangana State Center. I once again thank all the experts, all the eminent personalities, Sardar Tanvinder Singh Kokhli, Chairman, and Sardar Gagandeep Singh Kokhli, Vice Chairman of Guru Nanak Institutions, and Dr. H.S. Saini, Managing Director of the group, and Dr. Rishi Soil, Associate Director, Guru Nanak Institute of Technical Campus, and last but not least, Dr. P. Jagadishan, Professor and Head Department of Civil Engineering, Guru Nanak Institute of Technical Campus. I thank one and all for giving this opportunity to be before you. Thank you. Good morning. Welcome to the National Conference, or National E-Conference nowadays, on recent advances in civil engineering, that is a RACE-2020. I am Dr. MVSS Giridhar, working as a professor and Head, Center for Water Resources, Institute of Science and Technology, Jawaharlal Nehru Technological University, Hyderabad. Today, in the keynote address, I am trying to present on water conservation, rainwater harvesting, a new perspective. All of us knows water is very, very important. So water comes from the atmosphere in the form of a rainfall or snow. Whatever it is falling in the form of a rainfall, it need to be arrested and need to be stored and need to be conserved and used for all other purposes. So otherwise, whatever the water coming from the atmosphere, it touches the ground and starts moving on the ground and starts overflowing, and then after overflowing it fills all the gaps, ponds, lakes, and it moves to the rivers and it goes and joins into the sea. So what is the need of the water conservation? Now there are various ways of the water conservation. You might have seen, it's studied in the civil engineering. So starting from conservation in the agriculture, conservation in the municipality level, conservation in the villages, conservation in the household level. These are various ways as individual can do it. So water conservation with respect to the civil engineers, we are taking here, it is a new concept, rainwater harvesting and modified rainwater harvesting technology. So as we discussed just now, it is a water conservation water conservation can be saved in the agriculture field in the form of a micro irrigation. Water conservation can be done at household level to arresting the leakages or to minimize our water usage. Under the civilization, people are increasing the water consumption. Now we can minimize the water consumption. That's how we can save it at the household level. There are various ways to save the water at household level, but we are not discussing here. Maybe arresting the leakages, reduce the usage of washing machines and all. But water conservation, special topic we are taking, it is rainwater harvesting, and it is a need of the hour, and there is no rocket science in the rainwater harvesting technology. But somehow we are moving away from the nature and we are not doing the harvesting. And it is, as we discussed, rainwater harvesting is not a rocket science. It was happening thousands of years before, but somehow we are moving away from the nature. That's what we are going to discuss, rainwater harvesting, its need and artificial recharge. And we are also going to discuss what is a new concept in the rainwater harvesting, which we have done at the Jawaharlal Nehru Technological University campus, where we can harvest huge quantity of the water in a smaller place. And because we are sitting in a Hyderabad Deccan Plateau, after every 6 feet or 8 feet we will find a hard rock. So hard rock will not allow water to penetrate into the ground. So we modified the traditional methodology, what we are doing in the rainwater harvesting, the existing methodologies. That's what we said is a traditional methodologies. We modified, we improvised, we innovatively designed the rainwater harvesting systems suitable to the Hyderabad track and Hyderabad terrain. Not only Hyderabad terrain, suitable to across the globe. This is what my presentation in the next half an hour. So these are the topics we are going to discuss. So it is a flow of introduction, then water conservation, then rainwater harvesting, use and artificial recharge. Then we will see after understanding all the concept, what is the rainwater harvesting, need of the harvesting and artificial recharge, we are going to discuss success story of the JNTH, Jawaharlal Nehru Technological University, Hyderabad campus, innovative rainwater harvesting system. Rainwater harvesting system, and also we will see the success story of the fluoride concentration reduction at JPH campus. So we have seen what are the conservation various methods, rainwater harvesting, where most of the times, many times people will feel that what is the rainwater harvesting, where we can use it. So we can use rainwater harvesting for any purposes, starting from the drinking to domestic to industrial, agriculture and all other purposes. We can use rainwater harvesting, starting from drinking, domestic, agriculture, industrial, all purposes we can use. And only rainwater harvesting is the primary source of the water available from the nature. All other water is derived from the rainwater. If you take the water, various waters, rainwater, atmospheric water, soil water, salt water, underground water, lake water, river water, all this water is derived from the rainwater. So rainwater is the first water and all other water is secondary water. And rainwater is the pollution free with respect to the physical, chemical, biological and heavy metal contamination, and all other water may be contaminated with respect to the physical, chemical, biological and heavy metal contamination, depends on where the rain is falling. that depends on what type of land use, land cover. If the water falls in the agriculture area, it mixes with the fertilizer and pesticides which we have used for agriculture and gets contaminated down the line. If it falls in the industrial area, it mixes with the industrial pollution and moving down along with the effluents. If it falls on the landfills or the seaways or the sewer lines, it joins into the sewer lines and mixes with all the nutrients like nitrates, phosphates and all biological contamination. That depends on that. So what we have to do? We have to harvest the rain wherever it falls. Harvest the rain wherever it falls without flowing longer distance along the surface. So another point, the concept of it is artificial recharge. All of us knows the natural recharge is happening since thousands of years, but somehow we are converting permeable land into impermeable land. Most of the agriculture area is converted into various industries, various residential purposes for various developmental activities. We are converted the land from permeable to impermeable. So that is the need of our to go for a artificial recharge, because we have closed most of the natural recharges and it is a need for the artificial recharge. Otherwise, the water is taking from the underground, water level goes down, then it is a problem. As we are going deeper and deeper, it requires more power consumption. As we are going deeper and deeper, it also takes, it is also may not be giving the good quality of the water when compared with the rainwater. Understanding all this, we implemented the new methodologies, whatever we developed in the Center for Water Resources, implemented in the Jawaharlal Nehru Technological University campus, and we constructed nearly 24 recharge wells and along with the recharge storage structures, and all the water falling in the rain in the JNTU campus is injected into the ground and used for various domestic purposes and hostel students purposes, and we made our university is a zero discharge university with respect to the rainfall. Means a single drop of water we are not allowing to move away from the JNTH campus, and because the results is as the water we are injecting going down, the water level increase. Not only increasing the water levels and quantity, it is also increase the water quality, because we know the dilution concept. If you add fresh water into the polluted water, it gets diluted more and more, because the rainwater we understand is a fresh water without any pollution with respect to the physical, chemical, biological and heavy metal. Then we inject into the ground the polluted water. If it is polluted with the fluoride or polluted with arsenic or polluted with the salt water, when you add the rainwater into the ground, then the concentration gets diluted. With this concept, we applied the same procedure, the same methodology with the funds received from the Telangana State Council of Science and Technology by the Telangana government. We applied the same concept in the Nalgonda area. All of us knows Nalgonda is a highly affected with the fluoride concentration. So we are trying to inject the rainwater into the Nalgonda district in the Mariguda Mandal in the two ZPH Jilla Parishad High Schools campuses, and in the process dilution is happening, fluoride is improved, means concentration is reduced dramatically from 16 ppm to 2 ppm, 7 ppm to 1.5 ppm. Water is available very little for us. The liquid water is 13% of the 2.4%. Out of 13% available water from the lakes and river streams are 3%. We need to use this water very precisely, otherwise for the next generation it is not the sustainable water resources happening. So this is what I explained earlier, hydrological cycle. It is coming from rainfall coming in the form of from the atmosphere. Some of the water evaporates or holds in the atmosphere, then it comes and touches the ground, then stores surface water, then starts overflowing on the surface. We say it is a surface runoff, then comes and joins into the channels. This is what it is, a hydrological cycle. So wherever the water is falling, we should have a capacity to harvest it and use for all our domestic purposes. Excess water need to recharge in the form of a artificial recharge. This is what is happening with respect to the natural water cycle. So leftmost, if we see, it is a natural water cycle without any disturbance. Huge quantity of the water flowing in the sub-base flow. All the water infiltrates and base flow will be continued. The quantity of the water flowing in the river is huge and it is a continuous 365 days and evaporation is more. But because of the urban water cycle, if you see in the middle of the picture, urban water cycle, most of the area we converted from natural permeable land to impermeable land. In the process, base flow is reduced and started overflowing on the runoff, and this is the need of the hour for the rainwater harvesting in the form of a water conservation. So otherwise all the water flowing on the surface will move in the form of a runoff, and as the runoff moves in the same area, the width of the channel is same, the quantity of water increases, velocity increases, erosion increases. If the erosion increases, the river water bodies gets polluted and waste flow is reduced. And this is towards more sustainable water cycle. If you see in the rightmost side, and we need to go for an artificial recharge at each and every house, public places, government places, and all institutions. Everywhere we have to find out the mechanism to recharge the water into the ground. Whatever it is, contaminated water coming in the runoff, we need to go for a wetland. This is how we can have a sustainable urban water cycle. If this is not happening, there will be a lot of impacts. It creates the floods, and surface and groundwater gets contaminated, soil gets contaminated, base flow is reduced, availability of the groundwater will be very, very less. So Government of India has started Jal Shakti Abhiyan to check the water crisis in the drought hit taluks, and they said rainwater harvesting structures will be installed at all the government buildings, including schools and Gram Panchayat. This is the concept of the Government of India, and all the citizens are supposed to work along with this, and all we are living in the government or private, so we need to have a rainwater harvesting structures, make all our premises a zero discharge premises. So all the rainwater falling on our buildings need to be stored in the sump, all excess water need to be recharged, and whatever it is stored in the sumps can be used for all domestic purposes. These are the Jal Shakti Abhiyan 5. Jal Shakti Abhiyan focuses on 5 aspects: reuse and recharge structures, water conservation and rainwater harvesting, renovation of the traditional and other water bodies, watershed development, and intensive afforestation. So this is what it is as an individual, as a citizen of the country, as a citizen living as a human being in this on this globe, we can have a water conservation structures, and all we are living in is concrete buildings. So water falling on our rooftops can be collected, stored in the sump, and can be used for all our regular domestic purposes. Excess water can be recharged. So even climate change effects also, it is saying climate change and impact on the state of Telangana. The rainfall may be having extreme weather events, maybe less rainfall, less intensity, and high intensity rainfall. And whenever you have a high intensity rainfall, it is the need rainwater harvesting structures can be constructed, and all the water can be collected and you can store it. Otherwise, when the intensity of the rainfall is more, then percolation is less, then water flowing on the surface is more, and all the excess water goes and joins into rivers and sea, and it is a wastage of the rainfall in the form of a runoff, and fresh water goes and joins into the sewage tanks and it gets contaminated. So this is the need of the hour. In terms of the climate change and its impact, we need to have a rainwater harvesting. There is no other solution other than the rainwater harvesting, store and recharge. So this is as per the rational methodology, we know that the rainfall intensity, area is same, intensity of the rainfall is same, and only the coefficient changes. That is what we say, it is a Q is directly proportional to the area of the watershed, Q is directly proportional to the intensity of the rainfall, and removing the proportionality, Q is equal to constant multiplied by area multiplied by intensity of the rainfall. That constant is, we say it is a runoff coefficient. Maybe around 1970s, it is only 10% of the rainfall converts into runoff, means coefficient is only 0.1. Later it has moved to 55%, coefficient is 0.55, coefficient is 0.75. In some of the places where the development is huge, like high-tech city area in the Hyderabad and other areas, most of the permeable land converted into impermeable, almost 100% area is converted into impermeable, runoff coefficient is leads to 1. If the runoff coefficient is leads to 1, then all the rainfall, theoretically, hypothetically, all the rainfall is converting into the 100% runoff. So this is how it is happening, and see the erosion. Because the velocity increases, width of the river is same, and quantity of the water coming is huge, then velocity increases as per the law of conservation of mass. Q is equal to AV. As area is same, velocity increases. As the velocity increases, erosion happenings, and as the area is same, flooding may occur because of the runoff coefficient is increased. And if we see, all the stormwater may contain of the metals, nutrients, suspended solids, pesticides, hydrocarbons, carbons and microorganisms, because as we discussed earlier, water moving on the surface and mixes with the various land use, land cover, depends on type of land use, land cover, the contamination may come. Nutrients may come from the agriculture land, metals may come from the industries, suspended solids may come from the urban area, pesticides may come from the agriculture field, like that. Wherever water falls, if you are not harvesting, that fresh water is going down and mixes with the various contamination, depends on various types of land use and land cover. So this is what it is in nature given, and if you see it is a bottom, you can take it as a before summer, before rainy season, just before it will act as a dry sponge. When the water comes, because of the root system and because of the nature, it is most of the area is permeable and velocity reduces. The water starts going into the sponge and the water will be stored in the sponge. The dry sponge becomes wet sponge during the rainy season and releases the slowly into the river, into the canal. That's the reason we say it is a steady river flow. When the steady river flow is happening, 365 days water is flowing, base flow increases, groundwater level increases, maintain the ecosystem of the water body. And if you remove the nature, this is what it is for various land use, land cover. We converted from one type of land use to another type of land use, one type of land cover to another type of land use. Then in the process, it becomes a permeable land. All the water moves at a faster rate. The width of the river is more, quantity of the water is more, leads to flood, and all the water goes and joins into the sea. Base flow is less, and groundwater levels will go down deeper and deeper. So we need to have a water conservation structure wherever it is possible. Stop the water, not to allow to go into the downstreams, and stop it and inject into the ground. So various water conservation systems we are skipping. Then another point is the eutrophication. If you see, this is the freshwater ecosystem, but because of the contamination is happening everywhere, the sewage is allowed to move into the water bodies or freshwater ecosystem, because water moves from higher energy to lower energy. So whether it is a sewage water or rainwater, it moves and it joins into the water body. Now it is a water body, it is not the football stadium, and covers with the greenery like a water hyacinth or horseshoe plants or water hyacinth, and it freezes the sunlight penetration to the ground. As it covers the entire area 100%, the water will not receive any sun rays into the water, and it reduces the dissolved oxygen. When the dissolved oxygen reduces, then all water loving fishes and frogs will not survive and leads to eutrophication condition. So when the lake is reached to eutrophication condition, by going nearer to the lake body, we can understand that by seeing its smell or by seeing the color, it looks like a milky white color when it is reached to a eutrophication condition. When it reaches to eutrophication condition, means it's full of nutrients available like nitrates and phosphates, and the water, if this type of water goes into the ground, nitrogen and phosphorus contamination will be more in the groundwaters. When the groundwater it is contaminated with the nitrogen and phosphorus, it is not good for health for human beings. So we need to go for a rainwater harvesting to avoid all this. So this is what it is, a freshwater ecosystem people can enjoy with this. So rainwater harvesting and use, this is all today's thinking. The people are, even if you tilt the umbrella, within a fraction of a second we can fill the bowl, but we are dependent on the secondary water system. We are dependent on the secondary water system. This secondary water also derived from the rainwater, but we ignoring the basics. This, if we just tilt the umbrella, we can fill the bowl, but we are not doing this. So with this, we need to change our mindset, and we need to change our mindset, then collect the rainwater, collect the various mechanism to store the water, because it is a crystal clear water, fresh water without any pollution with respect to the physical, chemical, biological contamination. That water can be stored and all the properties maintained as per the Bureau of Indian Standards. So we can use that water for drinking as well as for all other purposes, and load will be reduced on the secondary water. So these are the rainwater harvesting. We discussed about urbanization, industrialization, civilization. We cannot stop urbanization, we cannot stop industrialization, we cannot stop civilization. Because of all these activities, water consumption is increasing like anything. Water consumption is increasing and water recharging is reducing, and it is the need of the hour to go for a rainwater harvesting. And once we decided to go for a rainwater harvesting, we need to identify which method is suitable. There are various methods available in rainwater harvesting systems available across the globe, but we modify and we improvise the system that we are going to discuss in the subsequent slides. So we also taken the study with respect to the water quality on the urban bodies. We are working in the Hyderabad, and it is around Greater Hyderabad Municipal Corporation. We are trying to study what is the water quality of the lakes. We have taken total 27 lakes with the different areas, and these are the list of the lakes, going with the smallest lake to the biggest lake to study the water quality parameters. These are the water bodies digitized using remote sensing and GIS and GPS. That's what we say it is a geospatial technology. And we found, after collecting the samples and we tested in the laboratories, we found the contamination may include in some of the lakes, it is organic and inorganic substances. Some tanks it is a human waste, some tanks it is agriculture waste is predominant, and some places we found food processing waste is coming directly joining into the lakes, partially treated or not treated at all. The chlorinated solvents, ammonia, chemicals, fertilizers and heavy metals, lots of things are joining and adding into the lakes. We also found out of 27 water samples, the range up to is a 1.5 is the average, and it is a fluoride contamination supposed to be below this 1.5, but out of 27, 24 samples are higher than the permissible limits given by the Government of India. So these are the problems we discussed. So now what is the solution for all this? So one problem we discussed with the climate change effect, another problem we discussed the water bodies are mixing with the various pollution. Then the solution is, the one and only solution is rainwater harvesting, use and artificial recharge. So rainwater is coming freely and falling on our rooftops. Rooftop, if you maintain clean, that water can be directed directly into the sump, and the water can be stored. If the water is stored, 360 water is stored without any open to the atmosphere or the sunlight. If the sump is not open directly to the sunlight, if it is closed and not allowing any sunlight to penetration into the sump, that water can be used for 365 days without any hesitation, without any problem. So that's what we said is rainwater harvesting use and artificial recharge. We need to identify the mechanism to recharge at a faster rate into the ground. So what we can do with the rainwater, we can harvest it, we can filter it, we can store it, and we can use it. If it is excess, then recharge it. So these are the simple steps in the rainwater harvesting. We need to harvest it, whether you are sitting in the concrete building or it is a AC seat roof building, water can be collected and we can harvest it. If needed, we need to go for a filtration. If some leaves are falling, or if the first rain can be separated, or we can filter it, then we can store it and we can use for 365 days starting from domestic purposes. If it is excess than your requirement, we can recharge. If it is excess than your requirement, we can recharge. And further, the water is not falling on your rooftop, means the water falls on the rooftop as well as other than the rooftops, on the roads, parks and other areas. The water falling on the roads or roof or gardens or other areas directly cannot be used for drinking because it is contaminated with the surface water and various types of land use, land cover that can be recharged after proper filtration. There are various advantages with the rainwater harvesting. So this is one of the advantages, and it is the only solution. Rainwater harvesting process has an inherent tendency to arrest the seawater ingress in the coastal areas. There is no other method, there is no other option except rainwater harvesting and injection to arrest the seawater ingress into the ground. So this is what we say, it is a sustainable rainwater harvesting system. Water falling on the rooftop can be stored into the tank and used for all domestic purposes. Excess water can be recharged either from the rooftop or water falling other than the rooftop can be recharged. This water goes and joins into your bore well, and you can take the water whenever there is no rain day. Whenever there is no rainfall is happening during the summer season and other seasons, you can take out the water from the bore well, and this bore well generally never dry if you have a rainwater harvesting system. That's what we say, it is a sustainable rainwater harvesting system. So all the premises, private and government, need to have this type of rainwater harvesting system. Step one is to store the water in the sump, making the rooftop clean and used for domestic purposes, other purposes. Other than the water or excess from the rooftop or water falling other than the rooftops can be recharged, and it will recharge the bore well. This is the sustainable urban water cycle. There are two types of classification of the rainwater harvesting as we discussed. One is a roof-based, other one is a land-based rainwater harvesting system. Roof-based more or less clean, and and without any chemical, biological and heavy metal contamination. There may be physical contamination, we can remove it by first rain separator. Land based we cannot use for directly for drinking and domestic purposes. This water can be recharged into the ground after proper filtration. So the components of the rainwater harvesting, it is a catchment area, then conveyance from rooftop to sump, then first rain separator. So sometimes we need to have a first rain separator, first 2 minutes. Nowadays we have an automatic first rain separator, we can have it. Then you can go for a filter unit, storage, delivery system, usage, then recharge. These are the components of the rainwater harvesting. It is a very simple and we have to practice it. And this is the calculation with respect to the rainfall and rooftop area, how much water we can store. As per that we can design the sump. And these are the various water harvesting methods available in the literature, and in the various methods we can select which one is useful for us, for our area as per the requirement. And these are the various components of the rural urban rainwater harvesting systems. You can have a small pit, allow the water. If it is a pervious soil, it goes into the down, and you can also harvest the water in a sloping groups through the gutters, collect it and put it into the sump. All the vertical pipelines can be connected horizontally, and we have to increase the pipe sets telescopically. So for all apartments we can use it. Already the building is constructed, the apartment is ready, pipelines are ready. Additionally, we are trying to connect all these vertical pipelines with the horizontal pipelines with the telescopically increasing. So this cost is very less, but huge quantity of the water can be collected. Otherwise, it goes as a waste and joins into the sewer lines, and all contamination may happen. Once it is contaminated, it is very, very difficult to bring it back to a fresh water. So if the soil is not permeable, then we can go for if it is impermeable strata, we can go for making a pipeline, making a hole into the impermeable strata and take the water from this level to this. So we can also add the water into the open wells. So working wells also we can add after filtration. Abandoned bore wells can be recharged after proper filtration, or working bore wells also we can recharge. So most of the times we are worried about the cost. So recharge pit in a household level, it costs only 2000 to 2005 approximate rate. And the recharge well with the injection well. Recharge well, when we say it is a storage as well as injecting into the ground, it costs nearly 50 to 80,000, depends on the local conditions. The cost may vary. This is the approximate rate we are giving. So after understanding all these basics, so we are trying to implement this in the JNTU campus. After understanding the basics and the need of the rainwater harvesting, at Center for Water Resources, Jawaharlal Technological University, working in the Water Resource Department, we thought we need to develop innovative rainwater harvesting or improvised rainwater harvesting system after understanding the various difficulties faced by the stakeholders. That's what we are trying to say. It is a success story at the JNTU campus. We constructed nearly 24 recharge structures. The list is given here, 1 lakh capacity, 1 lakh capacity at different places. These are some. All the rooftops available in the JNTU campus is now equipped with the rainwater harvesting system. Means water falling on our buildings directly goes into the sump. If it is excess, then it will go to the recharge. So all the water falling other than the rooftops also we are harvesting. The entire JNTU campus we divide into micro watersheds, and we found there are 4 micro watersheds in the campus, and at the end of at the mouth of the watershed we have gone for constructing a recharge pit along with the injection well. Some places it is a 1 bore well, some places it is 2 bore wells, some places it is a 3 bore wells, depends on the incoming quantity. If the runoff is more, we are going for 3 bore wells, 3 recharge wells at a different depths. One is 100 feet, another one is 150 feet, another one is 200 feet, as per the availability of aquifer zones tested with the resistivity meter. And we also have a piezometers to measure it at different places, 2 in the influenced area, 3rd one is in the non-influenced area, to see the impact of the rainwater harvesting system. And piezometer is built as per the central groundwater board with a depth of 30 meters on the downstream of the rainwater harvesting systems. And these are the recharge wells constructed at different places. This is constructed near the ground. All the water falling in the ground in the football stadium, the 5 acres campus, the water comes into the storm line This we stopped here by constructing a wall across along the width of a channel. Then water level rises, then flows into the rainwater harvesting system, and we have a one injection well after proper filtration. This sheet is having a perforated with a 125 microns geotextile woven type HDPE. This filters all the particles greater than 125 microns. The only particles less than 125 microns are 0.125 mm. That is very, very fine dust goes into the ground, grows into the next level or passes through this membrane, then filtered with the sand, filtered with the pebbles. Then after filtration, the water enters into this pipeline. This pipeline, we say it is a bore well, it is a recharge well. This takes the water from surface to the underground. How much underground, how deep it is, depends on the aquifers. We found in the campus there are two types of aquifer system. One is at a level of 65 to 100 feet, another at a level of 165 to 200 feet, and all these aquifers are empty. All these aquifers are empty before our initiation, before our involvement, before inception of this. Then after we started filling all those aquifers at a level of 65 to 100, 165 to 200. And this is another place, it is a mouth of the watershed, and it is a downstream for the entire university. All the water comes here, and that is the reason we have gone for a 3 bore wells, 3 recharge wells at a depth of 100 feet, 150 feet and 200 feet. These are the other open areas, different places. Just I am showing the picture. This is the sumps, the water coming and stored into the sump. This is the 1 lakh liters, and this is another sump connected from both the buildings. You can see the pipelines. The water comes and stores here. Excess water, we have given the mechanism to go and join into the recharge wells to recharge into the underground. This is another area. The pipeline is coming and joining into the sump. This is the 50,000 liter capacity. The water coming from the 4 buildings in this sump. And this is also another building where all the residential quarters are connected. And this is a 2 lakh liter sump, and designed the pipeline with the siphonic action, and all the water comes and stores, and it goes by gravity to the existing sump. There is no energy used in the entire rainwater harvesting systems. And these are the piezometer constructed different places. The purpose of the piezometer is we need to collect the samples during the pre-monsoon season and post-monsoon season to study the impact of the rainwater harvesting system. To study the impact of the rainwater harvesting system with respect to the quantitative and qualitatively. Every day morning 8 o'clock we measure the water level in the piezometer, and we are trying to find out what is the gap, lag. Today if the rain falls, how much time it is taking to reach into the piezometer, that we are trying to study scientifically. And we are collecting the samples pre-monsoon season, post-monsoon season, and all the 3 places to study all the 13 parameters given by the government of India as a standard. And we found before our intervention, before our starting of this rainwater harvesting, the quantity was not good when compared with after the rainwater harvesting. It means a lot of improvement in the quality. It is not only increasing the water levels, it is also improving the quality. As we discussed earlier, it is only on the principle of dilution. As the quantity of injection is more, then the dilution is more. That is the purpose of the piezometer. This is all during the construction photos. And if you see, this is the 1-inch hole we made, not the air cracks. It is a 1-inch hole, and there is no membrane or the mesh around this casing pipe. There is no membrane and mesh around the casing pipe. If you put the membrane around the casing pipe, then the water, when there is no rain, there is no runoff, the water goes to a 0 velocity. All the suspended solids try to settle here, and it may choke the mesh or membrane. That is the reason I advise, so better not to put the membrane or the mesh around the casing pipe. Make it 1-inch hole and leave it. And these are the various places. If you see very clearly, the pipes are connected, and these are the metals we placed different places. These are the pipelines connected to a sump. And this is the 4-layer mechanism we developed in our campus. Before that, it is only 3-layer mechanism. What is that 3-layer? If you have a ground level from this we go for a depth of D, make it a 4 parts, D by 4, D by 4, D by 4. First part is freeboard, the second part is core sand, third one is 5 to 12 mm or 20 mm stone, this 20 to 40 mm, and it is a bottom is a rock. This is what is the 3-layer existing in the traditional methodology. And there is no geotextile in the 3-layer, there is no recharge well. There is no geotextile and there is no recharge well in the 3-layer. This is what it is, the improvised system, and it is what it is, innovative rainwater harvesting system, modified system in the suitable to the urban areas, suitable to the granitic terrain. So what is the advantage with the geotextile is, we understand that this geotextile is a perforated geotextile with 125 micron hole size or 0.125 mm hole size perforation is there in the geotextile. Means all the dust particle greater than 125 micron will be settled on the top of the geotextile, and it doesn't adhere to the geotextile because it is a plastic in nature, HDP in nature. Or even if the water comes, even if you have not removed the settlements or the filtered material, if the rainfall comes, with the runoff comes with the huge velocity, this all puts one side and clear water enters it. Otherwise, if there is no geotextile, if the runoff comes, runoff we understand it consists of lots of sediments. Initially, sand will be act as a perforations, pervious layer. After some time, depends on the input quality. If the quality is not good, within 1 hour, within 1 day, the pervious layer converts into impervious layer. Then the top layer, after on the top of a sand, the impervious cake will be formed, a mud cake will be formed, and it becomes impervious. Even if the water comes, the cake will not allow the water to flow into the down. And we need to remove the cake, we need to remove the sand, clean it and put it again. This is a cumbersome process and requires lots of maintenance, and it is difficult to do at the private and public building. This is what we noticed when we interacted with the lots of users. People says it is a huge maintenance, but we modified by putting the geotextile on the top of it. Now it is a maintenance free. And another point is, we understand that is a 3 layers are given, bottom is a rock. When the water comes, filters to the sand, filter to this 20 mm and 40 mm, touches the ground, it is a rocky surface, then started building the water column up to the topsoil, up to the ground level. Once it touches the ground, it is a hard rock, and it is a building the water column up to the top of the ground level, then starts overflowing. So it is a namesake, and I say we may say that we have a rainwater harvesting system, but the effectiveness or efficiency is very, very less. After understanding this difficulty, we thought we need to make a hole into the hard rock. That's what we drilled the bore well, created a pipeline, created a hole from ground to subsurface till it reaches to the aquifers. That aquifer may be located at different places for different regions. We need to identify where those aquifers and recharge it, and it goes effectively, and it is 100% accurate, 100% water goes into the deeper layers. This is the video, shows about how the water coming and filtering, entering into the bore well. See, all the debris will be settled on the top. After filtration, it goes and joins into the pipeline. This is what we say it is a improvised rainwater harvesting systems. Like this, we have a 22 systems in the campus. All the 22 systems as a capable of harvesting nearly 10 crore liters in the campus. See the quantity of the water, huge quantities coming without any inundation, without ponding, is going into the deeper layers. This in the video of artificial recharge of the surplus runoff into the aquifers directly after filtration. Huge quantity of the water filtered after proper filtration without inundation. This is the suitable method for the Hyderabad, Deccan area and all other places where it is urbanization is more. And this is the quantity of the water collected various places during the years. So all the slides, and we also prepared the hydrographs. What is the lag time with respect to the rainfall and with respect to the groundwater levels. This research is going on in the campus in different places, were collected from the piezometers, and we are disseminating this information across the globe. It is available and it is well documented in the electronic and print media at various places, and with the results we found there is a drastic change, improvement in the quality, not only in terms of quantity. The same concept we try to implement in the highest fluoride affected area in the country, that is in Nalgonda. That is a fluoride concentration reduction using rainwater harvesting or injection into the aquifers. So this is the background of the project. See, this is how people are the laymen, they are not aware the water is contaminated with the fluoride. That's what it is happening there. Allowed is 0.5 to 1.5 ppm. Some places is 10 ppm, 12 ppm and all it is happening. The solution is either you go for a mission Bhagirath, the prestigious project started by the government of Telangana to give the water to each and every citizen in the state of Telangana without any polluted water, fresh water, clear water, or go for a mission Kakatiya, the water is harvested and this water gets filtered going down. As rainwater goes down, it improves the water quality. And we can also go for a defluorination. That is a brain water, reject water management is the toughest task here, and it is not advised to go for a RO system even by NGT because lots of water is rejected. The reject water concentration is much more than the original raw water. This is not the solution for the pollution. It is increasing the more pollution on the surface. So it is not advisable. Even though technology is available, it is not advisable. And this is the concept of what we are proposing, aquifer dilution through the injection. The huge quantity of the water going as a runoff and flooding the local areas, making the waterlogging area. Instead, make a hole, allow the water properly for filtration, then it goes and down, joins into the groundwater level increases, waterlogging reduces, mosquitoes generation reduces, and quality improves. This is the one case we are showing here. We have done 4 Jilla Parishad high schools we have taken and we have implemented this concept. This is the boundary of the Jilla Parishad. This can be done very easily by sitting in the office using the geospatial technology. This is the building and this is the mid-meal program is going on, and this is the bore well. They are using the water for the midday meal and all, except drinking. All other purposes they are using this bore well. We have taken various bore wells and upstream, downstream to study the impact, and this is our recharge well. Huge quantity of the water is coming and going this way, and we stopped here. This is the amount of the watershed this, and we have injected the water into this. These are the various photos during the construction stage for understanding purpose. So the same awareness is created for the people. So this is black diagram of that. Then if you observe here, at the time of drilling, before our intervention, in the school premises, if you see horizontally, at the school premises in year 2017, it is 7.45 ppm. Allowed is only 1.5 ppm. See, there is a huge quantity, 7.45. This water, if you use even for cooking, the residuals will be there in that water we are drinking. After intervention in the first rain, it is reduced to 6.28, then further reduced to, after rainy season, 2.4 in the September 2020, and it is a 1.36. And it is in the behind the school, so another bore well. So this is how it is, water is reduced. Outside the school campus, initially before our intervention, 5.09 to 1.06. Newly drilled 5.16 to 3.15. Another bore well 5.3 to 2.57. There is some places it is a more than 1.5, but still it is a dramatic change from the inception. This quality keep on improving by increasing the quantity of the water, adding into the water. This can be applied in various places wherever the water quality have a problem with respect to the fluoride, with respect to the main water, with respect to the salt water, with respect to the arsenic. Then we can use this concept because it is a very simple dilution. Rainwater we are trying to add into the aquifers and it gets diluted and increasing the water quality. So finally, after after rainwater harvesting can be undertaken through a variety of ways, capture the runoff from the rooftops. After this lecture, maybe go and study where is the water falling on your rooftop and how it is going, whether that pipeline is connected onto the road or connected to the sewer lines. Then if it is connected to the sump, it is fine. Otherwise, immediately action taken is vertical pipeline, then connect with the horizontal pipeline. That horizontal pipeline need to connect to the sump. Don't waste a single drop of water. So that water can be used for all other purposes. Capturing the runoff from the local catchments that we discussed can go for injection bore well. Capturing the seasonal flood water from the local stream, conserving the water through the watershed management. So for the final conclusion, it is very easy for maintaining. Whatever the systems we design, it is a maintenance free and no wastage of rainwater in the form of a runoff. Large amount of water can be collected for harvesting, improves the groundwater levels and improves the water quality. It's not only improving the quality and quantity. End of the day, as a civil engineers, we can say that proudly we have done something to the service as a service to the society. Thank you. Thanks for patient listening.
Thank you for your valuable speech, sir.
Thank you for your inspirational speech, sir. The session will be continued after the break. I request all the participants to get ready with your presentations. Thank you.